we saw that if we have, for example, a scalar equation and that scalar equation has a discontinuous solution in the very beginning meaning at t is equal to 0, then we have q left if x is less than 0 and q right if x is greater than 0. This was all about scalar equation or scalar problem. Now in this video we will discuss the same thing, Riemann problem, but for system of equation. The notation changes. Suppose we have a system of equation and this is written in conservative form. The initial condition is q left if x is less than 0 and q right if x is greater than 0. This solution shows that there is a discontinuity. If I draw that over here, it means there is x is equal to 0. On the left hand side, I have q left, and on the right hand side, I have q right. It can happen that when we have x is equal to 0, x less than 0 can be q left, and on the right hand side when this is x less than 0, this is x greater than 0, this becomes q right. Okay, so there is a discontinuity. Where is that discontinuity? This is the discontinuity in the solution. Discontinuity. Okay, so what will be the solution in that case? Remember that when we have a discontinuity, the discontinuity is like this. This is not a part of solution. There is a gap. Here is a gap. This is at t is equal to 0. When time passes, that part moves towards right, and this part also moves over here, and we have a new point, and the discontinuity has traveled a distance. Here, if it is x is equal to 0, then this becomes, it depends how many system of equations we have. In this case, for example, if we have only one and u bar is greater than 0, the next point is x is equal to u bar t. So the initial solution has moved towards the next point and we have solution available there. If we have, for example, two equations, then we have two values. For example, this can be density and this can be pressure, so on. So such system is called Riemann problem. This is called Riemann problem, and we already discussed that the point will move towards the right or towards the left. It depends what is u bar or whatever the lambda is, if there are eigenvalues or there are eigenvectors. When we have a system of equation, remember, for system of equation, we need to discuss that for eigenvalues and eigenvectors. Eigenvalues and eigenvectors. Okay, so why does this matter? If I go back towards the advection equation, for advection equation we have partial q by partial x is equal to 0. Here you can see that I have only scalar value, which is 1 cross 1, which is a scalar value, and q is also a scalar value. When we have a system of equation, then this changes into a vector, and here we have a matrix, and here again we have a vector, column vector. That's how the things changes. Then we talk about the eigenvalues and eigenvectors, which we already discussed before. Okay, now the question is, how can we write a solution of this system of equation when we have a Riemann problem? Previously we saw that if we have a problem which does not contain any discontinuous solution, we have a solution like this: q is equal to wp rp, p is equal to 1 to m. It means that for a system of equation, first we need to convert, for system of equation we need to convert that problem into w. We transform that equation into w, plus there will be lambda partial wp by partial x is equal to 0, where this is a diagonal matrix, and in this diagonal matrix we have eigenvalues. For example, we have partial w1 by partial t plus lambda 1 partial w1 by partial x is equal to 0 for first wave. And if you just compare that with advection equation, it looks for scalar problem, it look like this. That is the aim. We transform this problem into an advection equation, and then we have a solution like this. Then this was the solution when we have a continuous problem. If we have a discontinuous problem, for discontinuous problem, the left side, q left, will be equal to p is equal to 1 to m, and wp l r p. Similarly, for the right side, for this q right, we have a solution q r p is equal to 1 to m wp r p. That's how the solution changes. Okay, let me just solve one simple equation. For example, we have a Euler equation. Example, suppose we have Euler equation You must have studied this Euler equation in fluid mechanics. Euler equation contains a system of three equations. The first one is continuity, the second one is momentum, and third one is energy equation. So it means that we have three equations. We have three equations, and it means that P is equal to 1, 2, 3. So we have three waves. Here we have written Q left and Q right for M waves. If there are M waves, as a mathematician, when we talk about many waves, we build a theory for general problem, but when we have a particular value, particular system of equation, then we transform that general theory into the particular one. So we have three equations. It means that we have three eigenvectors and we have three eigenvalues and so on. The solution will look like this if there is an initial Riemann problem. Riemann problem is that problem where we have discontinuous solution in the beginning. That is called Riemann problem. So the solution will become Q left is equal to W1 left R1 plus W2 left R2, W3 left R3. Here, these all things are called eigenvectors that we already discussed before. And similarly, we have Q right. Q right will be equal to W1 R R1, W2 R R2, W3 R R3. And similarly, when we have converted our problem over this problem into the W form, the initial condition will also change. So let me just write the initial condition as well. Remember that we have a partial WP by partial T plus lambda 1 partial W 1 by partial X is equal to 0, partial W2 by partial T lambda 2 partial W2 by partial X is equal to 0, partial W3 by partial T plus lambda 3 partial W3 by partial X is equal to 0. That is our system of equation. What we do, we write, since this equation is in terms of W1, W2 and W3, so the initial condition will also look like this. W naught X is equal to WP left if X is less than 0, and we have WP right if X is greater than 0. This is our initial problem, initial Riemann problem in terms of W. Remember that it is similar to the Q, partial Q by partial T plus U bar partial Q by partial X is equal to 0 for scalar problem. When we have converted the system of equation into the W1, W2 and W3 for three waves, then we also have W naught as an initial condition. So this becomes, the solution becomes WPXT. Remember, I have to repeat this again. Partial Q by partial T U bar partial Q by partial X is equal to 0. Qx0 is Q left if X is less than 0. Q right if X is greater than 0. And we remember that if we have such a solution, it just translates. So this becomes Q left, Q right if X is less than U bar T, if X is greater than U bar T. So it is like this when we have X is equal to, T is equal to 0, and then the same problem has, the same initial condition has moved towards right. That point is U bar T. If X is less than U bar T, we have Q left. When X is greater than U bar T, then we have Q right. So the solution is WP left if X is less than. Remember that we have lambda 1, lambda 2, and lambda 3. So it means that we have X less than lambda PT. So we write lambda PT and WP right if X is greater than lambda PT. I just took an example of 3 waves. So here this P will be equal to 1, 2, and 3. And the same goes to this P. P will be equal to 1, 2, 3. And the same goes to the this eigenvalue P is equal to 1, 2, 3. So this was all about the solution. But remember, I just have to write, although the video is a bit longer, but we have to write the solution, the complete solution. Qxt will be equal to the P1 to capital P, WP right R of P plus P is equal to capital P to M, WP left R of P. This has a solution. What is capital P? It just shows that uh, which eigenvalue or which scalar function or the eigenvector is important. For example, if we have two eigenvalues or two eigenvectors are important, then this will be equal to P1 to 2 W P R RP plus, and if we have left, for example, P2 to 3, if there are three eigenvalues, three system of equation, then we have WP left RP. So it should be a combination of right and left. Okay. So this capital P shows that your which wave is important. We will talk about that in future video. Thank you for watching.